In this example, we will be discussing the declaration and initialization of variables. The goal is to evaluate the expression. In order to achieve this goal, we must work through each of the subgoals. The first subgoal is to determine the resultant data type of the expression. The second subgoal is to update the variables for any pre-operators, noting any side effects. The third subgoal is to solve the arithmetic equation using operator precedence. In other words, determine the value of the expression. The fourth subgoal applies to assignment statements. If there is an assignment statement, is the left-hand side a variable? Check the data type of the copied value against the data type of the variable. And finally, the fifth subgoal. Update the variables for post operators, noting any side effects. Now we will apply these subgoals to our first example. Evaluate these statements. If the statement is invalid, give the reason. If the statement is valid, what are the values of the variables? Then we are given the declaration of several different variables. The code can be broken into two kinds of statements. The first two lines are the declaration statements, followed by additional assignments. To begin, we will work through the first subgoal, determine the resultant data type of the expression. Let's look at the declaration statements. Alpha, beta, and gamma are all declared as integers. Beta is assigned the value of 1, which is an integer and legal. Omega, theta, and lambda are declared as doubles, decimal numbers. Omega is assigned the value of 2.5, which is a double and legal. Alpha is assigned the value 42. The value 42 is an integer. Theta is assigned the value 4. The value 4 is an integer. Gamma is assigned the value 0.0. The value 0.0 is a double. Lambda is assigned the value of beta. Beta is an integer. Subgoals 2 and 3 are not used in this example. Now we move on to the fourth subgoal. For the assignment statements, is the left-hand side of the assignment statement a variable? Check the data type of the copied value against the data type of the variable. First we have alpha. Alpha is assigned the value of 42. Alpha is a variable of type integer. 42 is an integer, and you can assign an integer to an integer. Next we have theta. Theta is assigned the value 4. Theta is a variable and is declared of type double. You can assign an integer to a double. The integer value 4 is promoted by adding a 0.0 to it, so it becomes 4.0. So 4.0 is copied into theta. Next we have gamma. Gamma is assigned the value 0.0. Gamma is a variable and is declared of type integer. You cannot assign a double to an integer. This statement is invalid. And finally we have lambda. Lambda is assigned the value of beta. Lambda is a variable. You can assign an integer to a double. The integer value in beta, 1, is promoted by adding a 0.0 to it, so it becomes 1.0. So 1.0 is copied into lambda. Subgoal 5 is not used in this example. This brings us to our final answer. Alpha contains the value 42, beta contains the value 1, omega contains the value 2.5, theta contains the value 4.0, and lambda contains the value 1.0. Gamma results in a compilation error because you cannot assign a double to an integer.